Hello everyone, my name is Bino, and in this video we are going to explore some key vector concept. We'll be determining the angle between two vectors, we'll be calculating the dot product, and also understand the vector magnitudes. Suppose we have a vector A with the following coordinates: A subscript x for the x coordinate, A subscript y for the y coordinate, A subscript z for the z coordinate, and another vector B with the following coordinate: B subscript x for the x coordinate, B subscript y for the y coordinate, and B subscript z for the z coordinate. The dot product of A and B denoted by A dot B will be equals to the x coordinate of A multiplied by the x coordinate of B. A subscript x multiplied by B subscript x plus the y coordinate of A multiplied by the y coordinate of B, A subscript y multiplied by B subscript y, plus the z coordinate of A multiplied by the z coordinate of B, A subscript z multiplied by B subscript z. The dot product of A and B, A dot B, can also be defined as the magnitude of A multiplied by the magnitude or the length of B multiplied by the cos of theta, where the magnitude of A or the length of A will be defined by the square root of the sum of the squares of the individual coordinates. That is A subscript x squared plus A subscript y squared plus A subscript z squared. And the magnitude or the length of B will be equal to the square root of the sum of the square of the individual coordinates of B. That is B subscript x squared plus B subscript y squared plus B subscript z squared. And angle theta is defined as the smallest angle between vectors A and B. The first question, we have to determine the dot product of vectors A and B. So let's copy and paste our formula for the dot product. The dot product A dot B will be equal to the x coordinate of A multiplied by the x coordinate of B, 2 into -1, plus the y coordinate of A multiplied by the y coordinate of B, plus the z coordinate of A multiplied by the z coordinate of B. A dot B will be equal to -2 plus 20, which will be equal to positive 18. The result of this dot product of two vectors is a scalar. Moving on to the second question, we have to determine the angle between the two vectors A and B. We copy and paste our formula. We start by determining the length of A, which is equals to A subscript x squared plus A subscript y squared plus A subscript z squared. This will be equals to the coordinates of A. The sum of the coordinates of A is squared. So the 3 squared plus negative 2 squared plus the 5 squared. So the length or the magnitude of A will be equals to 3 squared is equals to 9, and 4 squared, negative 4 squared is equals to 4, and the 5 squared will be equals to 25. We have the 9, the positive 4, and the positive 25, and this will be equals to 9 plus 4 is equals to 13, and 13 plus 25 will be equals to 38. So we have the square root of 38 as our magnitude for A, and for the magnitude of B, we have the square root of B subscript x squared plus B subscript y squared plus B subscript z squared. We have the square root of the 1 squared plus positive 4 squared plus negative 3 squared. The magnitude of B will be equals to the square root of 1 plus 16 plus 9, which is equals to the square root of 26. Remember, we have to determine the angle theta, which is between vector A and vector B. We already determined the magnitude of A and B. Now we have to compute the dot product of A and B. So A dot B will be equals to the x coordinate of A, the 3, multiplied by the x coordinate of B, plus the y coordinate of A multiplied by the y coordinate of B, plus the z coordinate of A multiplied by the z coordinate of B, and this will be equals to 3 minus 8 minus 15. Our A dot B will be equals to 3 minus 8, which is equals to negative 5, minus 15, which is equals to negative 20. Our formula, once again, we have A dot B, which is equals to the magnitude of A multiplied by the magnitude of B multiplied by cos of theta. We already determined A dot B as negative 20, and the magnitude of A as the square root of 38, and the magnitude of B is equals to the square root of 26. Remember, we are looking for theta, the angle between vector A and B. So let's make cos theta the subject of the formula. Cos theta will be equals to negative 20. We divide through the equation by the square root of 38 multiplied by the square root of 26. Our angle theta will be equals to the arc cos of negative 20 divided by the square root of 38 multiplied by the square root of 26. Angle theta will be equals to, in radians, 2.26 rad, and in degrees our theta will be equals to 129.52 degrees From here, let's define the relationship between two vectors A and B if they are perpendicular. If vector A and B are perpendicular or orthogonal, then the dot product of A and B will be equals to 0. Vector A, represented in vector component notation as A subscript x, A subscript y, A subscript z, is equals to vector A represented in unit vector component as A subscript x multiplied by I plus A subscript y multiplied by j plus A subscript z multiplied by k. In the same way, vector B in vector component notation, B subscript x, B subscript y, and B subscript z is equal to the unit vector notation B subscript x multiplied by I plus B subscript y multiplied by j plus B subscript z multiplied by k. Our last question, we have to show that vector 2i plus 2j minus k is orthogonal to vector 5i minus 4j plus 2k. So we are going to compute the dot product of the two vectors and see if they will be equals to 0. We have 2i plus 2j minus k. In the vector component notation, we have 2 and the 2 and the negative 1. And we also have vector 5i minus 4j plus 2k given in unit vector notation, and in vector component notation we have 5 minus 4 and positive 2, and we can call the first vector A and the second vector we call it vector B. The dot product of A and B will be equals to the x coordinate of A and B multiplied plus the y coordinates of A and B also multiplied plus the z coordinates of A and B multiplied the negative 2 and the positive 2. 2 multiplied by 5 is equals to 10, and 2 multiplied by negative 4 is equals to negative 8. Negative 1 times 2 is equals to negative 2. A dot B will be equals to 10 minus 8, which is equals to positive 2, minus 2, which is equals to 0. Therefore, A and B are orthogonal or perpendicular.